Hello everyone, I am Akash. In today's video, we will solve an interesting MCQ question on closed and connected subsets of R. We will solve this question via two approaches, one by geometric and another by theoretical approach. So watch till end of this video for step-by-step solution and surprising insight that might change the way you think about these concepts. So let's get started. We have given two different subsets of R2. One is A, which is set of ordered pair xy belongs to R2 such that x and y are integers. Another is B, which is a set of ordered pair xy belongs to R2 such that y equals to x square. Then, which of these given statements are true? So let's start with the statement in A. Statement in A is complement of A in R2, that is R2 minus A, is closed. Is this a true statement? No, this is a false statement. To see it, let's first write what is R2 minus A. That is complement of A in R2 is a set of ordered pair xy belongs to R2 such that at least one of x and y is not an integer. Okay. So this is R2 minus A, that is complement of A in R2. Because if at least one of x and y is not an integer, then such an ordered pair does not belongs to A. Because ordered pairs in A are such that both of these coordinates are integers. So such an ordered pair belongs to complement of A. So this is the definition of complement of A in R2. Now, note that for every n greater than 1 belongs to set of natural number, the sequence xn, which is the sequence of ordered pairs defined by 1 over n comma 0, belongs to R2 minus A. Because for every n greater than 1, 1 over n is not an integer. So this ordered pair belongs to R2 minus A. For every n greater than 1 belongs to natural number. So this is a sequence of ordered pairs in R2 minus A. Okay. But clearly xn converges to ordered pair 0 comma 0. Okay. And this ordered pair does not belongs to R2 minus A. Why? Because both of these coordinates are integers. But here we must have at least one of these coordinates is not an integer. Here both of these coordinates are integer. So 0 comma 0, this ordered pair does not belongs to R2 minus A. So there exists a sequence in R2 minus A which converges to a point which is not in R2 minus A. So this implies R2 minus A, that is complement of A in R2, is not closed. Okay, because this will be a limit point of the set R2 minus A, which does not belongs to R2 minus A. So R2 minus A is not closed. So the statement in A is incorrect. Another way to see it is clearly this set A is a discrete subset of R2. This is a discrete subset of R2. So it has no limit point. The set A has no limit point. So set of limit points of A, that is A dash, that is derived set of A, is empty set. Okay. But we know that closure of A equals to A union derived set of A, that is A union A dash. So this is equals to A union empty set, which is equals to A. Okay. So closure of A equals to A. So this implies A is closed set. So this implies A is closed subset of R2. But this implies complement of A in R2, that is A minus R2, is open. Okay, because A is closed, So its complement in R2 is open. So this is open set. It is not a closed set. So the statement in A is incorrect. So we mark it as incorrect. Now let's move to the statement in B. The statement in B is R2 minus A, that is complement of A in R2, is connected. Is this a true statement? Yes, this is a true statement. To see it, we note the result that if S subset of R2 is countable set, is if S subset of R2 is a countable set, then R2 minus S, that is complement of S in R2, is path connected, okay, and hence connected, okay. Now observe that what is A. Clearly A is nothing but direct product of Z with itself, Z cross Z, because A is a set of ordered pair xy belongs to R2 such that x and y both are integers, and we know that Z direct product with itself is a countable subset of R2, okay. So by this result, this imply R2 minus A, that is complement of A in R2, is path connected, okay, and hence connected, because we know that every path connected set is connected. So complement of A in R2 is connected. So the statement in B is a true statement. Now let's see it geometrically. Let's draw xy plane, that is R2, okay. Now let's take point P with coordinates x1, y1 and Q with coordinates x2, y2, and both of these points belongs to R2 minus A, okay. Both of these points P and Q belongs to R2 minus A. Now we have seen the definition of R2 minus A. What is R2 minus A? R2 minus A is a set of ordered pair xy belongs to R2 such that at least one of x comma y is not an integer, okay. We have seen this definition in statement in A, okay. So this is R2 minus A. So by definition of R2 minus A, as these 2 points belongs to R2 minus A, so at least one of these 2 coordinate is not an integer. At least one of these 2 coordinate is not an integer. So without loss of generality, say x1 is not an integer and y2 is not an integer, okay. So case first, x1 does not belongs to z and y2 does not belongs to z, okay. This is by definition of R2 minus A. Suppose point P is something here, okay. This is P x1 y1 and say point Q is here, okay. This is say Q x2 y2. Now draw a line which passes through the point P, vertical line, okay. This line is given by equation x equals to x1. Now observe that every point on this line has first coordinate x1, because x1 is not changing, x1 is fixed. So every point on this line has first coordinate x1, but x1 does not belong to it. So by definition of R2 minus A, for every point on this line, its first coordinate is not an integer and hence every point on this line is an element of R2 minus A. So this line is contained in R2 minus A, okay. Now draw a line, horizontal line like this, okay, passing through Q. This is given by y equals to y2. Okay. Now observe that every point on this horizontal line has second coordinate y2 because y2 is not changing. Okay. What is changing? X coordinate is changing. That is x2 is changing. But the y2, that is second coordinate, is not changing. It is fixed. So every point on this horizontal line has a second coordinate y2. But y2 does not belongs to z. Okay. Y2 does not belongs to z. So every point on this horizontal line has a second coordinate which is not an integer, has a second coordinate y2 which is not an integer. So by definition of r2 minus a, we have every point on this horizontal line belongs to r2 minus a. Okay, that means this line, horizontal line, is also containing r2 minus a. Okay, so for any two points P and Q in R2 minus A, that is complement of A in R2, we have a path, okay, we have a path joining P and Q, okay, we have a path joining P and Q which is completely contained in R2 minus A, okay, which is completely contained in R2 minus A. So R2 minus A is path connected. Note that there are other cases too. For example, other case is x1, y1, other non-trivial case is x1, y1, that is both of these coordinate does not belongs to z, and both of these coordinates x2, y2 does not belongs to z. In this case too, you can use the same argument and show that the path is completely contained in R2 minus A. Okay. So in all cases, you can easily show that the set R2 minus A is path connected and hence it is a connected. So the statement in B is a true statement. So we mark it as correct. Okay. Now let's move to the statement in C. The statement in C is R2 minus B, that is complement of B in R2 is closed. Is this a true statement? No. This is also a false statement. To see it, let's see it geometrically. Let's draw XY plane. Okay. What is B? B is a set of ordered pairs belongs to R2 such that y equals to x square, that is second coordinate equals to first coordinate square. Okay. So it is a set of points which lie on this parabola. Okay. B is a set of points in R2 which lie on this parabola y equals to x square. So what will be R2 minus B? R2 minus B is a set of points which lie here, okay, that is which lie in this shaded portion and which do not lie on this parabola. So R2 minus B, okay, that is this shaded portion is R2 minus B. Okay. Now, is this shaded portion, that is R2 minus B, is closed? No. We can easily show that this shaded portion, that is R2 minus B, is an open subset of R2. To see it, let P be any point in R2 minus B. Say P be the point, say here. Okay, this is the point P. And let epsilon be the distance of P to the nearest point of B. Let epsilon be the distance of P to the nearest point of B. Okay, so this distance is epsilon. Then it is clear that n epsilon by 2 of P, that is open ball with center P and radius epsilon by 2. Open ball with center P and radius epsilon by 2. Okay, so that open ball will look like this something. Okay, this is a point P. Okay, so open ball with center P and radius epsilon by 2 is clearly contained in this shaded portion, that is contained in R2 minus P. Okay. So point P will be interior point of R2 minus, because there exists a neighborhood of P which is completely contained in R2 minus. So point P will be interior point of R2 minus. And this is true for every point P belongs to R2 minus. You can take point P very near to B. Okay, this clearly this point P is very near to B. It will look like something this. Okay, this is P, and this is a distance of P from the point nearest point on the parabola. You can take half of this distance as a radius of this neighborhood, and clearly that neighborhood is again contained in R2 minus P. Okay, so this is true for every point P belongs to R2 minus P. So we see that every point of R2 minus P is an interior point of R2 minus P. And by definition of open set, we know that a subset S of metric space is open if every point of S is an interior point of S. As here, every point of R2 minus B is an interior point of R2 minus B. So we conclude that R2 minus B is an open subset of R. So the statement in C is incorrect because it states that it is a closed subset of R2. However, it is an open subset of R2. Now let's move to the statement in D. Statement in D is R2 minus B, that is complement of B in R2, is connected. Is this a true statement? No, this is also a false statement. To see it, we note a result that let S be an open subset of R2. Then S is connected if and only if S is path connected. Okay. Clearly, here we have shown that R2 minus B is an open subset of R2. So we can use this result, take S equals to R2 minus B. Okay. Then S is connected if and only if S is path connected. And what is R2 minus B? R2 minus B is this shaded portion. Is this shaded portion is path connected? Is this shaded portion is path connected? No. This shaded portion is not a path connected. To see it, take any 2 points, say the point Q here and point R here. Okay. Now, can you draw a path from Q to R? Okay. Can you draw a path from Q to R which completely lie inside this shaded portion? That is, which completely lies inside R2 minus B? No, because such a path must intersect this parabola at some point, say M. Okay, clearly this path intersects this parabola at point M, and as the point M lies on this parabola, that is M belongs to B, so M does not belongs to R2 minus B. Okay, so this path has, this line has the point which does not belongs to R2 minus B. So this path, that is the line, is not subset of, let's denote this line by L. Okay, so L is not a subset of R2 minus B because it contains a point M which does not belongs to R2 minus B. So the line L is not a subset of R2 minus B. So we see that for any 2 points in R2 minus B, we cannot draw a path which joins that 2 points and lie completely inside R2 minus B. Okay, you cannot draw a path like this. Even if you draw a path like this, then that path must be intersected by this parabola somewhere. Okay, because this is going to infinity and this is also going to infinity. So for any path joining these 2 points, okay, so any path joining these 2 points is not contained in R2 minus B. So R2 minus B is not path connected. Okay. So from this result, as this is an if and only if type result, okay. So as R2 minus B is not path connected, so R2 minus B is not connected. Okay. So the statement in D, that is R2 minus B is connected, is false, because R2 minus B is not path connected. So R2 minus B is not connected. So we mark it as incorrect. So the correct answer to this question is statement B is a true statement, and all other statements, that is A, C and D, are false statements. Okay. So if you found this video interesting and helpful, then please like and share this video and subscribe to our YouTube channel. Thank you for watching.